So I've talked a bunch about different types of angles we can do, radians, degrees, different types of degrees with the DMS format. So now there's a couple of things we're going to talk about with angles. One of these things I already mentioned a little bit when I was talking about the vocab on the first couple pages of the purple packet. So now we're going to focus more on different representations that we can have for angles. And so what that is called is a coterminal angle. So there's two sides of an angle. There's the initial side and the terminal side. So the initial side is where it starts, and the initial side is always along the positive half of the x-axis. And then the terminal side is where the angle stops to create that angle shape. And so the terminal side will change depending on how much we want to rotate. And the reason why they're called coterminal angles is because there's actually several different ways we can represent that terminal side of the angle depending on how the direction we rotate. And actually there's a way we can over-rotate, because if you look, where it's going to continue going around, and it can go around in a circle. So we can actually have several different representations for multiple angles. So if something's a coterminal angle, it has the same terminal side, it's just a different angle measurement. And we can do these measurements in angles, in degrees, sorry, or radians. Okay, so we can use both representations for all those angles. So we'll have a mixture of the two, and again, it's pretty easy to tell whether something's a degree or a radian just based off of what it starts with. Degrees has that degree symbol. Radians typically have pi. So you'll be able to notice what representation you're using. So that kind of affects how we find coterminal angles, just depending on whether or not our angle starts as a degree or a radian. And whatever it starts in, I know we talked about converting, and you can go back and forth, but if an angle starts in degrees, when I ask you to find coterminal angles for that, I want you to give me 2 degree measurements. So I don't want you to have to convert anything. Same thing with radians. If I give you an angle measurement in radians, I want you to find me 2 coterminal angles in radians. So we're going to keep it in the original format, and that will make more sense when I get to the examples. But so there's 2 different ways we can find a coterminal angle to the initial angle measurement that you're given. So say you're given, and these are labeled with alphas and betas, or you can think of it as A and B. If you're given this original rotation, which remember positive rotation is your counterclockwise rotation. So I could give you the positive rotation for this angle, the terminal side. So I would be starting from the initial side and rotating counterclockwise to get that angle, whatever angle measurement you want to give that. So we could give that representation, or I could give you the representation of a negative angle. The way we get negative angles is starting from the initial side and rotating clockwise instead of counterclockwise. Okay, so those would be 2 representations of that same angle. Again, just one's a positive rotation and one's negative rotation. So what can happen is, if you notice, this kind of makes a full circle. If I give you the positive angle measurement, we can actually just find the negative angle measurement just by doing a little bit of subtraction. Because like I said, this whole thing makes a full circle. So we can use a whole rotation. If I give you a positive angle, we can subtract a whole rotation from that angle, and that'll give us the clockwise rotation, or the negative representation. So you find it by subtracting 360. If you have a positive degree, you can subtract 360 from it, because then what that'll do is it'll go negatively around the circle and end up back in that same position. Because 360 is a whole rotation. So if I've given you the positive angle for that, if you subtract 360 from that, that'll actually take the whole trip around the circle negatively. And so you can subtract 360 if we're in degrees. Now if we're in radians, a whole rotation in radians is 2 pi. So if I give you the radian measurement, that's a positive angle. So again, to get to here, to get the negative radian measurement, you subtract 2 pi, which is a whole rotation. That'll rotate you negatively back into that spot. Okay, so since it kind of makes a full circle, we can use a whole rotation to either radians or degrees to come up with a coterminal angle with that. If I just give you one angle, you can find the second one by subtracting 360. Or another way we can find it is I give you a positive rotation, I can actually come up with another positive angle just by adding another rotation. So you basically over-rotate it. So if I give you this initial positive angle right here, what I labeled with the picture's labeled with an alpha, but it looks like an A. I can actually get to that same side by just rotating one more time around the circle. So I can add another rotation, and what that'll do, it'll just take me another trip around to get to that angle again. So again, it kind of over-rotates. Does that make sense? So essentially what we're going to, I'll give you one representation for an angle, and then I ask you to find me two more, okay? So it's pretty straightforward. Whatever representation I give you, you need to add a rotation to it. That gives you another rotation. It's just over-rotated into that spot. And or you subtract, and that'll get you a negative representation for that angle as well. Okay? So you take whatever angle I give you, you add a rotation, that'll just over-rotate that initial angle I give you, and get you in that same spot, so it'll give you a more positive angle. Or if I want a negative angle from that initial positive angle I give you, you subtract 360 or 2 pi from it, or a rotation. That'll get you a negative representation of that. Makes sense? Okay. So, like I said, typically the direction is find one positive, one negative coterminal angle given the original angle. And again, whether we use 360 or 2 pi, it's 360 if it's a degree, 2 pi if it's a radian, because a whole trip around the circle in degrees is 360, a whole trip around the circle in radians is 2 pi. So let's do a couple of examples. So I'm going to give you an original representation. Now I could give you a positive or negative angle to start with. It doesn't matter if it's positive or negative. We're still going to add 360 or 2 pi and subtract 360 or 2 pi. So you're going to do that each time. So you're going to either add a rotation or subtract a rotation. And if you do that, you'll find two other representations of that angle. One that's more positive and one that's negative. Okay? So if I take 80, so is 80 a degree or a radian? Degree. So what's a whole trip around a circle in degrees? 360. Yep. So initially, I would start with the addition. You can actually subtract first if you want. So to find another angle that's in the same terminal side as an 80-degree angle, if you add 360, take another trip around the circle, that'll get you another representation that would follow that same angle measurement of 80 degrees. So it's 80 plus 360. Yep. So one coterminal angle. 440 degrees. Okay. I don't ask you to draw too many angles, but to kind of give you a little bit of visualization for that. So 90 degrees would be this one. So our 80-degree measurement would be here. So that initial 80 degrees is right here. 440 would be a whole nother trip around. That's where our 440 would be. Okay. I don't usually with this, a lot of times you're asked to draw the angles. I don't typically make you do that, but I will at least draw you one for our first example. So that's our original 80-degree measurement roughly. 440 takes your whole trip around and back to that spot. And then I want to find a negative coterminal angle. So then what can I do with my 80 degrees? I can subtract. Okay? What that'll give me is instead of rotating counterclockwise, the negative subtracting will give us this negative angle, or the clockwise rotation, to get from the initial side to that terminal side, rotating clockwise instead of counterclockwise. So we're going to take 80 minus 360, which is what? 280. Yep. Negative 280. Okay? So the negative 280 is this rotation, starting from the initial side, rotating clockwise now up to that 80-degree original angle. So that would be the negative 280 rotation. Okay. So now we have one positive and one negative coterminal angle to our initial angle. Questions about the first one? Did the picture kind of help visualize where the angles were? Okay. So you won't have to do that every single time. But like I said, that kind of helps you see that we're all ending in the same spot. It's just one is just this initial little rotation One's this over rotation, and one's that clockwise rotation to get to it. Okay. So then my second angle, is that a radian or degree? Radian. Okay. So now when I add and subtract the whole trip around the circle, what's a whole trip around the circle in radians? 2 pi.
I had two options, okay? I'm so wrong. You didn't have 180 wasn't an option. 360 or 2 pi.
Yep. So last week we talked about how the equivalents are 2 pi 360 or rotation, half rotations pi 180. But we use that because it's simpler for us for our conversions. But with this, we have to use a whole rotation. So we have to use 360 and 2 pi. Those two things are equivalent. So then here's where the trick is with radians. They're fractions, and we need to leave them as fractions. So we're still going to add 2 pi to this to get another angle measurement. But now since we're adding with fractions, what do we have to have when we add fractions? Same denominator. Yep. So what you're going to have to do always is make that 2 pi into a fraction, which is 2 pi over 1. And then you need to come up with a common denominator so that I can actually add that to it. So the nice thing is, we actually already know what our denominator is going to be. It's going to have to match this one, because this denominator under 2 pi is always going to be 1. So how can I make the denominator 2 pi 4? Okay. So I need to make it the same as what I start with. So it needs to be a 4. So I can't just change the denominator to 4. What's my pi going to change to? 8 pi. Yeah, just multiply the whole thing by 2. Or sorry, 4. It said 4 and I wrote it as 4 instead of pi. So like I said, the nice thing is the common denominator is very apparent for us because we're initially starting with 2 pi over 1 every single time. So we just have to make it match the denominator that's there. So it needs to be a 4, so you multiply it by 4. So 2 pi over 1 becomes 8 pi over 4. And then we can add. And remember, when you add fractions, once you have the denominator, that is your denominator, it stays the same. So we just need to add up how many pi's we have. So if I take negative pi and I add 8 pi's to it, how many pi's do I have? So So a positive representation for negative pi over 4 is 7 pi over 4. So that's my one positive coterminal angle. So now I need another negative representation for that. So I'm going to take that initial angle, and instead of adding 2 pi, I'm going to subtract 2 pi. Which, when I subtract fractions, what do I have to have? Common denominator. What's my common denominator going to be? 4. So really, I'm going to take negative pi over 4, and I'm going to subtract 8 pi over 4 again. So I need to multiply that by 4 again. So you just add and subtract the same thing each time. It's just now, when we added, we got 7 pi. Now when we subtract, again, when we subtract fractions, once you have the common denominator that is your denominator, so you just need to subtract the numerators. So if I have a negative pi and subtract 8 pi from it, how many pi's do I have? Negative 9. There's my radian measurements. Okay, questions about positive and negative coterminal angles? That's good. Okay. So there's a little bit of fraction work when you work with radians, but like I said, you're always adding or subtracting 2 pi over 1, and you always have to make a common denominator. So the denominator is pretty straightforward because it's already there. You just need to change your 2 pi over 1 into something over however many pi's over the denominator that you start with. So if this had been 5 pi over 3, we didn't even make that into a 3. So it would be 6 pi over 3. If it had been 7 pi over 12, you need to make it into a 12. So it would be 24 pi over 3. Or 24 pi over 12. Okay? So like I said, you're working with some fractions. I know not everybody likes fractions, but it's pretty straightforward because you know the denominator needs to be, so you need to change it each time. So that's one thing we're talking about. The next thing we're talking about is a couple of formulas. Because we're rotating around circles, we can actually find different things within our circle using the angle measurement. The angle measurement has to be in radians in order for this to work. So last time we talked about this little thing. This gave us a radian. Okay. So the way the radian measurements came about was it found that angle using the ratio between an arc length, which is S, and the radius of the circle. Okay. So that theta is a radian, and what it is, it's a ratio between an arc length of the circle and a radius of the circle. Okay. So then they thought, well, since we use that to find a radian, how about we revamp the formula a little bit? And so now we can find arc length. So it just took that radian formula and it just revamped it, so instead of having theta equals, it's now S equals. So all it did was multiply the radius over with the radian. So R is still radius. And the theta is the radian measurement of that angle. So this only works if your angle measurement is in radians. So I was yelling when I typed this, but I did want to emphasize. So this only works to find an arc length of the circle is if you're given a radius and an angle that's in radians. So if you're given an angle that's in degrees, what do you need to do with the degree measurement? Yep, convert the angle into a radian. So before you can use this little quick multiplication formula to find an arc length, you just have to make sure your angle measurement's radian before you can use it. Okay. And then with these, notice the direction goes back to round. So I know typically up to this point when we're working with radians, we leave it as exact values, we leave the pies. With this one, we're actually finding a measurement. So this one, we're actually going to solve it out. So if you see that word, again, in your direction, we're going to solve it out as much as we can. So we're going to round to the nearest tenth. Okay, so in order to find arc length, I need to give you an angle measurement in radians and a radius. And then what I do with those is I just multiply them together. Okay, so that's what my little formula is. Arc length equals radius times radian. Okay, so multiplication here. So if I'm given my R, actually give, okay, 4 inches, is my angle measurement a radian? Yeah. Yes, okay. So do I have to worry about my big bold letters here? No. Okay. So again, since my angle measurement is already given to me as a radian, and my radius is already given to me to find arc length, I just need to take my radius, which is 4, times my radian, which is pi over 3. Okay, so I have 4 pi over 3. Now, I have to pay attention to the direction of mass to round that. Okay, so how can I round that? Well, I have to take 4 times 5, which is 12.566663, 7 little bunch of stuff, and then divide that by 3. So I have 4.18879. So we're going to say that that's 4.2. So again, just leave it, everything is exact unless you see that word in the directions round, then go ahead and solve it out. So just take, I took 4 times pi, divided it by 3, so I got 4.2. Questions about that one? Not sure why I have so many examples of this, but again, my arc length formula is just a really quick multiplication. It's a radius times the circle times the radian of that circle. And really what it's finding, imagine a circle, we have our radius, that's what the R is, so it's like 5 here. 2 pi over 3 is like roughly there. So what it's finding is it's this distance. Okay. So we know that this angle is 2 pi over 3. Okay. So the arc length is finding this little bit of the circle. Just that little part of the circumference. Okay. So I have a radius. Is my angle measurement in radians for this next example? Yes, it's 2 pi over 3. So I don't have to worry about converting anything. So I just need to take my radius, which is 5, times my radians, which is 2 pi over 3. So that's going to be 10 pi over 3. And again, I'm asked to round. So I'm going to take 10 times pi, which is 31.4159 to 1, divided by 3. So I get 10.47919. So it's 10.5 meters. Questions on my second example? Alright, so my third example, which I may just stop there and not do the fourth one because I think we're good to go with this one. What's different about this next example though? You have to convert it. Yeah, it's a degree, not a radian. So I have to convert. Because the way I find arc length is it's radius times radian. That is not a radian, that is a degree, so I have to convert it into radians. How can I convert the degree into a radian? What did we do today on today's theme?
Pi over 1.
Yep, pi over 180. Okay. Now I will say, if I'm just asking you to convert, and that's it, I'm really looking for the simplest form. So if you want to try to do that, that's usually what I do. But if you don't quite get it down to the simplest form, that's okay, because I'm at least going to simplify it a little bit. I noticed both, it was 125 and 180, so I divided them both by 5. So you could simplify it a little bit. That just helps you with numbers later, so you're not working with quite such large numbers. But if you don't quite get it in its simplest form before you plug it in the formula, you should be fine. You're just going to work with bigger numbers. So unless I specifically, the only direction you have is to convert. If you don't quite get it in simplest form, that should be okay. Does that make sense? My arc length is my radius, which is 7, times my radian. I simplify that to 25 pi over 36. So I just need to multiply that out. So I have 175 pi over 36, so again I round, so 175 times pi is 549.778 meters on, divide that by 36, so I get 15.271, I'm going to do 15.3, and now what's my label? 7 meters. Are you okay with if we skip example 4? Yeah, we can do that. Okay. Alright, so questions on finding arc length. It's a very simple formula. It's radius times radians. So if you have a radius and radians to start with, great, perfect, multiply them together. If you don't have a radian yet, if it's a degree, convert it, then take your radius times radian. Alright, last little thing. The other thing that happens with this is if you're given a radius and a radian, you can actually not just only find the arc length, this little distance, you can actually find the area of that little wedge that's created. Okay, so we use it to find the arc length. So we use it to find this little distance of the circle, but we can also use the same bits of information to actually find this little area that's shaded in blue on my screen, but not shaded on yours because it had to get copied. So. The formula is just a little bit different, but it does look a little bit shaded. Okay, so it's the same information. It's a radius and an angle in radians. Okay, and actually, I could show you where all this comes from. It's like it's a little bit the area of the triangle. It's a little bit of the radius or the arc length formula. It all kind of jumbles together. I'm just going to give you the formula. I hope that's okay. But like I said, this kind of forms from, it's kind of like a triangle, kind of like, but it's not really, it's more like a pie piece. So it kind of, that's where the area formula stems from. Like I said, I'm just going to give it to you. Essentially, it comes from the triangle because the triangle formula is a 1/2 base times height. And then it's not quite a triangle because it's a rounded edge. So I have to incorporate the arc length in there with it. So essentially what comes out from it is area equals 1/2 times the radius squared times your angle in radians. Okay? And again, I'm not trying to yell, I'm just trying to emphasize this works with an angle in radians. So if you're given an angle in degrees, what do you have to do? Convert it before you use the formula.
Not trying to yell. That sounds pretty.
I know. I was just trying to emphasize because another way you can check work is radian measurements are usually in between 0 and 2 pi, which we know pi is 3.14, so 2 pi is a little bit over 6. So you're working with an angle measurements that's somewhere in between 0 and 6. So if you're working with a degree measurement that's like 300, when you multiply this out, you're going to get a huge area. And so if you get something that's very large, then probably what you forgot to do is convert your angle. Okay? So that's another thing you can use to help check. Now that doesn't mean that we're not going to work with some areas that are large. Like if you're trying to find an area for almost the entire wow, I'm tired. Circle, and you have a very large radius. So say you're working with a radius of 20, and you're trying to find almost the entire area of the circle. So it doesn't mean that we won't necessarily work with large areas, but if you're getting something that's really huge, then probably what happened is you forgot to convert that degree into a radian. Because like I said, our radian measurements are going to be anywhere between 0 and 6, a little over 6, and our degrees could be between 0 and 360. Okay, so that's one thing you can use to help check the work. Okay. So same bits of information. We need a radius of a circle and a radian measurement of the angle, and we can use that to find the area of that little pie piece. We need a radius and a radian. Alright. Sometimes I give you pictures of this, sometimes I give you a little situation behind it, other times I just give you the information. So here I am giving you the radius of a circle, it's 5 meters, okay? And we're looking for an angle of 3 pi over 4. Okay? You don't have to draw it, but I like to visualize it a little bit. So we're saying that this is 5. 3 pi over 4 is like here-ish. Okay? So what we're doing is we're finding this area of that little pie piece. Okay? So I have my radius, so I'll set up my area. So 1/2 radius squared, so 5 squared. And then I need my radian measurement. Is my angle in radians?
Yeah.
Yes, it is. So I just need to take 3 pi over 4, so I don't need to worry about converting. So I just need to solve that out. Okay? And I am asking you to, I forgot to type this, round to nearest. Okay? So, you can solve out a little bit, but if you show me the setup, you should be good to go. So we'll do 25, because that's 5 squared, half of that, and then take it times 3 pi, and then divide it by 4. So I get 29.5. And since we're talking about area, what do we do to my units? Perfect. Like I said, we don't necessarily show all the little steps. So I did 5 squared first because you need to do the exponent. Then I did half of that, and then I took it times 3 pi over 4. Okay?
I'm not 30.
30.
So I think what I did is I simplified 3 times pi over 4 to 2.4.
Yeah. So if you round there in the middle, it's going to give it a little bit off. So I would always do the squared first, half that, then take it times the top part of the radian, so times 3 pi, and then divide that by 4. So if you round this part, your answer might be a little bit off. Alright, what's different about the second example?
Degree.
It's in degrees. What do I need to do with this degree? Convert it. Multiply by pi over 180. So I'm at least going to take off the zeros. You certainly could simplify that down a little bit more if you wanted to. I'm actually going to go ahead and do that because it's pretty quick. You just need to divide them by 2. I always try to simplify it because then you're working with smaller numbers in the end. So again, we have our area, 1/2 radius squared times our angle. 11 pi over 9. Okay. Again, if you left it in a different format, you should still get the same answer. So 8 squared versus 64, half that. 10 times 11 pi. And then divide that by 9. Make sure that works. 64
Ooh.
times 11 times 5 divided by 9. So 122.89 or 887